Welcome back to my channel. Today we are going to discuss about the transportation problem. In the previous video we have already done with the northwest corner rule, and today we are going to do with the least cost method, or we can call it as a matrix minima method. Okay, we'll take up a simple problem, then we'll try to solve the problem. Okay, transportation problem. Already we have done with the first method. For the initial basic feasible solution, we have already discussed regarding the what is basic feasible solution, what is initial basic feasible solution, what is a balanced transportation problem, and what is unbalanced transportation problem, what is degeneracy, matrix column with rows and columns. Okay, now today we are going to do with the least cost method. The second method, or we can call it as least cost method or matrix minima method. Okay students, so for the least cost method we have taken a problem. A firm has 3 plants located in a state and the units have to transport it to 4 destinations. So how many plants are there? P1, P2 and P3. So how many from out of these plants the units of 5 have to be transported to D1 destination, and 8 units to D2 destination, 7 units to D3 destinations, and 14 units to D4 destinations. So how many number of units are available with the plant 1? 7 units are available with the plant 1, 9 units are available with the plant 2, and 8 units are available with the plant 3. Before starting the calculations part, let's find out whether it is a balanced transportation problem or a unbalanced transportation problem. Let's calculate the total of supply. 7 plus 9, 16, 16 plus 18, 34, and regarding the demand, 5 plus 8, 13, 13 plus 7, 20, 20 plus 14, 34. Yes, it is absolutely a okay. So in the least cost method, out of all these transportation costs that have been given in the problem, we have to pick out the cell which has the least minimum cost. So I could able to find out 8 is the least cost, then we have to move on to the next highest 10, then from after 10 next highest 19, after 19 20, then 20, after 20 30, and after 30 40, then after 40 50. Like this we have to pick out the cells which have the least cost so that we can allocate the number of units in that particular cells. So finally the objective is to find out the minimum transportation cost, or it is called as a least transportation cost. So okay, let's start the calculations. Okay, now pick out this cell which has the least minimum cost, that is 8. Then compare the 8 units demand with the supply. The demand is less, so we can pick out the 8 units from the plant 3. We can transport to destination 2. So if we deduct 18 out of 8, still 10 units are available with the plant 3. So we have ruled out this column 2. Now we cannot allocate any of the units in these particular cells because this column has been ruled out. Okay, then after 8, move on to the next least cost, that is 10. Okay, so compare the demand with the supply. Here the supply is very less with the plant 1. Only 7 units are available with the plant 1, but the demand is 14. So we have to pick out the 7 units out of the plant 1 and transport to D4 destination. Okay, now this has been ruled out. Okay, it has been cut out to 0 out of 14 units. Still 7 units have to be transported to D4 destination. Got clear? And here this first row also have been ruled out. We cannot allocate any units in this particular first row. So what are the columns and rows are available with us? The first column is available, third column is available, fourth column is available, and second row and the third row is also available. Okay, now after 10, here we have 20. The next least highest is 20. Okay, here the 7, if we allocate this 7 here, 7 plus 7, 14. So it is going to get ruled out. So we have pick out these 7 units from the pick out the 7 units out of 10 units from the plant 3 and transport to D4. Okay, so 7 units out of 10 units pick out and transport to D4, and this also have been ruled out. This fourth column also have been ruled out. So out of 10 units, still 3 units are available with the plant 3. Okay, now what are the rows and columns are available here? Second row, third row is available, first column and third column is available. So after 20, with the available cost that we have, where we have to balance and transport the units from these particular plants, we have to transport to D1 and D3. Let's see. Okay, after 20, because this second column have been ruled out, we cannot allocate any units in these particular cells because this second column have been ruled out. Okay, so after 20, 30, we cannot allocate any units here. So after 30, the next highest least cost is 40. Okay, so compare the demand with the supply. Here the demand is 7 and the supply is 9 units that is available with the plant 2. Okay, now pick up these 7 units out of 9 units and transport to the destination 3, and this also have been ruled out. Okay, now out of 9, if we deduct 7 out of 9 minus 7, still 2 units are available. Okay, and this third column also have been ruled out. Okay, now what are the cells and columns are available with us? Second row, third row, and only first column is available with us, because here the 5 units demand is still left over, and here 2 units are available with the plant 2 and 3 units are available with the plant 3. Let's see, can we pick these 2 units from the plant 2 and transport to the D1. Okay, and pick this, and this also have been ruled out, exhausted, and pick out this 3 units from the plant 3 and this also. Okay, here out of 5, still 3 units are left over, demand still, it has to be transported to D1, and here 3 units are still available with the plant 3 and still 3 units have to be transported to the destination 1. Okay, now pick out these 3 units from the plant 3 and transport to destination 1. Here this demand also have been ruled out, exhausted. Now that all the rows and all the columns have been balanced. Okay, let's check out. Here 7 got balanced, 2 plus 7 9 also got balanced, and 3 plus 8 11 plus 7 18 also got balanced. Here 2 plus 3 5 got balanced, 8 got balanced, 7 got balanced, 7 plus 7 14 also got balanced. Now we have to take out those particular cells where the number of units have been allocated in these particular cells to find out the least cost transportation cost. Okay, so we can call it as a least cost or minimum transportation cost. Now pick up those cells where the numbers have been allocated or the units have been allocated. 2 into 70 plus 7 into 10, 7 into 20. Okay, now let's calculate. Here 140, 140. Now here the total least cost or the total transportation cost with the least cost method is 814 rupees. This is the minimum transportation cost that we could able to calculate with the method called least cost method or matrix minima method. Already we have discussed in the northwest corner rule that objective function and the constraints that have been framed in the form of a matrix method, in the form of a rows, and also in the form of a columns. Okay, so what is the rule it has to get satisfied? M plus n minus 1. So what is m here? M is sources and n is the destinations minus 1. And how many rows are there? 3 rows are there. And how many columns are there? 4 columns are there. Is equal to 7 minus 1 is equal to 6. Must and should be with this m plus n minus 1. This equation has to get fulfilled or satisfied. Let's see whether the 6 allocations we could able to get with this least cost method. 1, 2, 3, 4, 5, 6. Yes, we got a 6 allocations in this particular cells. Yes students, I hope you have understood the least cost method transportation problem in detail.